Salam, peace be upon you. My name is Mohammed Layiq Sediqi, the father of Holophase. Part 37. Generating General Relativity. Curvature as Phi's geometric paragraph. Remember the language we are learning. There is one field, phi, the holophase. One continuous cyclic movement from which all of reality unfolds. When phi begins to change, its first derivatives appear. And with them, the three dimensions show themselves at once. Time as omega, space as k, and motion as v, built from both. Every higher derivative is a finer question about how phi changes, and each one casts three shadows together: a time shadow, a space shadow, and a motion shadow. These echoes mix and weave into one another, forming the patterns we call fields, particles, bodies, thoughts, and worlds. In this picture, everything that exists is a living tapestry of phi, endlessly echoing through its derivatives and their dimensional shadows. Today, we listen to just one of those echoes. We stand at the final majestic peak of synthesis of physics. Our ascent through Ep.9 has been a revelation in unity. We have learned to read the cosmos as a single self-writing text. We've translated the dialects of force, Newton, light, Maxwell, and probability, quantum. Each translation revealed a deeper layer of the underlying phi grammar. But there remains one dialect, perhaps the most profound, the dialect that describes not the actors on the stage, but the warp and weave of the stage itself. This is the theory of general relativity, Einstein's masterpiece where gravity is not a force, but the curvature of spacetime. Today, in part 37, Generating General Relativity, Curvature as Phi's Geometric Paragraph, we undertake our ultimate act of translation. We must show how the very geometry of reality, the distances, durations, and causal pathways that form the arena for everything else, can be woven from the threads of a single field that knows no geometry to begin with. Our anchor image is a master weaver creating a three-dimensional tapestry on a loom that is itself made from the growing tapestry. The threads, phi, cross and interlace. Where the weave is tight and dense, it pulls the fabric into valleys. Where it is loose and stretched, it forms hills. The pattern of the weave defines the landscape upon which later threads are laid. The loom and the artwork are one. Today, we are that weaver, understanding how the phi tapestry, through the patterns of its own interlacement, creates the hills and valleys we experience as gravity. Here is the supreme puzzle of this part. General relativity treats spacetime as a dynamic, curved manifold, described by a metric tensor, a mathematical object that tells us how to measure distances and intervals. Our holophase foundation starts with a field phi that takes simple cyclic values. It has no inherent metric, no predefined spacetime. So how can a metric and its curvature emerge? How can gravity be a story phi tells about its own internal relationships, rather than a force propagating on a background? The answer is a story of relational geometry and collective stiffening. It proposes that what we perceive as spacetime is not a container. It is a network of relationships between events, and these relationships are dictated by the collective, large-scale organization of the phi field. The metric is a summary of these relationships, and its curvature reflects how those relationships change from place to place due to the presence of concentrated phi patterns we call matter and energy. Let's build this concept step by step. Forget space and time as primitives. Think of the universe as an infinite set of events or happenings. Each happening is a point where phi has a particular value and a particular pattern of change, its derivatives. Now, how do we decide which happenings are close together and which are far apart? In pre-relativity physics, we used an invisible, rigid grid. In phi physics, there is no grid. Closeness must be defined relationally, by how easily or strongly the phi state at one happening influences the phi state at another. This is where derivatives become geometry. The first derivatives of phi, omega, temporal change, and k, spatial wiggles, tell us about local rates of change. But to compare phi between two nearby happenings, we need to know how these derivatives themselves change. This is the second derivative, the curvature of phi. Now imagine looking at a vast, coherent structure within phi, a stable, large-scale pattern like the cosmic web of galaxies or even the vacuum state itself. Within this coherent structure, the relationships between phi values at different points become highly organized and stable. From this organization, we can construct a measurement rod. Technically, we construct the metric tensor, which we can call G for gravity, from combinations of phi's first derivatives. Specifically, we look at quantities like the gradients of phi and how they correlate. In the simplest models, the interval, the fundamental measure of distance between two events, can be related to an integral of the change in phi's phase or amplitude along a path connecting them. When phi is smooth and gently varying, these derivatives define a flat, Euclidean, or Minkowskian metric. This is empty space. Now, what causes curvature? Concentrated phi activity. Remember our lumps and topological defects? An electron, a proton, a star. These are persistent, intense knots of phi activity. In their vicinity, the derivatives of phi are not gentle. They are strong, twisted, and rapidly changing. This local intensification and twisting of phi's derivative patterns warps the effective relationship network. The way phi values connect from point to point becomes distorted. When we compute our effective metric G from these distorted derivatives, it comes out curved. The presence of matter, phi knots, has told the relational network to bend. So here is the point. Spacetime curvature is not something imposed on phi. It is a secondary, emergent description of how phi's own internal relationships are organized in the presence of intense, localized phi configurations. The stage bends because the actors are standing in particularly dense parts of the tapestry, pulling the weave tight around them. This leads us to the heart of general relativity, Einstein's field equations. These are the grammatical rules that link curvature, geometry, to matter energy, phi activity. In standard form, they are written as a compact equation. G equals 8 pi g times t, where G, the Einstein tensor, is a complicated measure of spacetime curvature derived from the metric G, and T, the stress energy tensor, is a measure of the density and flux of mass energy. In our phi language, both sides of this equation are effective, large-scale descriptions of phi structures. The left side, G, curvature, is computed from the effective metric G, which is itself constructed from the coarse-grained derivatives of phi. The right side, T, matter energy, is also constructed from phi. It represents the intensity, flow, and pressure of the phi configurations that we identify as particles, fields, and radiation. Recall our energy rule. Energy is a tally of the intensity of change in phi. The stress energy tensor T is essentially a detailed, multi-directional accounting of this change intensity and its momentum. Therefore, Einstein's equation, in phi language, reads something like: the curvature of the emergent relational network, from phi derivatives, is proportional to the distribution and flow of intense phi activity. It is not a law imposed from outside. It is a consistency condition that emerges when you try to build a stable, self-consistent, coarse-grained description of a universe made of phi. If the phi activity is arranged this way, the relational network must curve that way for the overall story to be coherent. Let's explore the tri-unity of general relativity emerging from phi. The time echo of gravity, gravitational time dilation. Clocks run slower in a gravitational well. Why? In phi language, time is measured by the cyclic rhythm of some stable process, for example, the oscillation of a cesium atom. This rhythm is set by the local phi frequency, omega. In a region of intense phi activity, a gravity well, the local derivatives are distorted. The effective rate of change for processes tied to phi is slowed relative to regions with gentle phi activity. The time echo is the stretched beat. The deeper the well, the slower the local rhythm, the greater the time dilation. The space echo of gravity, the bending of light. Light follows the straightest possible paths in the curved relational network, paths called geodesics. As starlight passes near the sun's intense phi activity, its mass, warps the network. The straight path for light is now curved from our flat space perspective. The space echo is the deflected beam, a visible testimony that the geometry of relationships is not flat where phi is knotted. The motion echo of gravity, orbital precession. Mercury's orbit slowly rotates, its perihelion precesses. Newtonian gravity, assuming flat space, couldn't fully explain it. In curved space, the straightest closed orbit in a warped network is not a perfect ellipse. It's a rosette. The motion echo is the drifting ellipse, the slow, inevitable shift caused by the curvature of the stage upon which the planet moves. Now, let's locate this grand final synthesis on the master tree. This is the capstone node of book 9.9 and arguably of the entire episode 9. The general relativity synthesis node depends utterly on all previous syntheses. It needs the concept of lumps and energy from classical mechanics, the idea of fields from electromagnetism, and the concept of coarse graining and effective description from quantum mechanics. It enables nothing less than a complete, unified view of physics as the story of phi. This node is the architectural keystone. It supports the entire vault of known physics by showing that even the arena is part of the performance. To visualize this, let's light lanterns from domains where the medium and the message are inseparable. A near lantern from a trampoline. This is the classic analogy, but now with a phi twist. The trampoline fabric is like a simplified two-dimensional version of the phi tapestry's relational network. It is flat when undisturbed. Place a heavy ball, a phi knot, matter, on it. The fabric deforms, creating a curved valley. The curvature is the fabric's response to the concentrated presence. A rolling marble, light, or a planet follows the curved fabric, appearing to be attracted. The fabric and the deformation are not separate. The deformation is a state of the fabric. The metric is the local stretching of the mesh. A middle lantern from traffic flow in a city. The city's road network defines distance in terms of travel time. Normally, it takes 10 minutes to go from A to B. Now, imagine a massive event at the stadium, a concentration of activity. The surrounding roads become congested. The effective metric for travel is warped. Distances, travel times, are now longer near the stadium. The shortest path between 2 points might detour far around it. The curvature of the traffic network is induced by the concentration of cars and people. The network and its usage are one system. A far lantern from the history of gravity itself. Newton saw gravity as a mysterious, instantaneous force acting across empty space. Einstein, pondering the equivalence of acceleration and gravity, realized that if you're in a free-falling elevator, you feel weightless. Gravity vanishes locally. This led him to the revolutionary idea: gravity is not a force in spacetime, but a feature of spacetime. He then spent years searching for the mathematical link between matter and geometry, eventually finding his field equations. Our synthesis continues this arc. Einstein replaced Newton's force with geometry. We are now proposing that geometry itself is not fundamental, but an emergent feature of the relational structure of a more primitive entity, phi. What is the specific language all of general relativity within Holophase? It is the grammar of the arena. It is the set of production rules that dictate how the phi tapestry, when viewed at a large scale, defines the very notions of here, there, now, and later, for the stories that play out upon it. It translates between descriptions of phi patterns, there is a dense knot here, and descriptions of the resulting stage. The interval between events is given by this curved metric. The core question this part asks about phi is, can the large-scale collective organization of phi and its derivatives give rise to an effective dynamical geometry whose equations of motion coincide with Einstein's general relativity, and can the phi configurations we identify as matter and energy serve as the source for that curvature? We are moving from asking how phi writes stories on a stage to asking how it weaves the stage itself. What does this synthesis do? It completes the unification, bringing the last pillar of fundamental physics, gravity, into the phi fold. It geometrizes matter and energizes geometry, showing there are two sides of the same phi coin. It provides a potential path to quantum gravity, because both quantum theory and gravity now have a common root in phi. Quantizing phi might lead to a theory of quantum spacetime. It demystifies the seemingly magical connection between matter and spacetime curvature, framing it as a self-consistency requirement. Now, stability and change. This GR synthesis holds in the classical macroscopic regime where quantum fluctuations of geometry are negligible. It is our best description of cosmology and astrophysics. It breaks down at the Planck scale, incredibly small distances, or in the final moments of a black hole collapse, where the derivative patterns of phi become so extreme that our smooth metric description likely fails. This is the boundary we discussed earlier. the realm where the phi grammar itself may need extension. This brings us to the crucial falsifiability thread. The claim is monumental and must face the most precise tests in all of physics. The prediction spine. Any phi model claiming to generate general relativity must, in appropriate limits, reproduce. 1. The Newtonian limit. For weak gravity and low speeds, it must yield Newton's inverse square law of gravitation. 2. Classical tests. The precise angle by which starlight is deflected by the sun. Gravitational redshift. The slowing of clocks/lowering of light frequency in a gravitational field. Perihelion precession of Mercury. The exact 43 arcseconds per century not explained by Newton. 3. Modern precision tests. Frame dragging, for example, from the Gravity Probe B satellite. Equivalence principle. All objects fall the same way, to exquisite precision. Binary pulsar decay. The slow in spiral of orbiting neutron stars due to energy loss via gravitational waves. 4. Gravitational waves themselves. The phi model must predict ripples in the emergent metric that travel at the speed of light and match the waveforms observed by LIGO and Virgo from merging black holes. The fail condition, falsification. 1. Approximation failure. If the phi-derived Einstein equations cannot, even as an approximation, match the precision of the above tests. For instance, if it predicts Mercury's precession to be 30 or 60 arcseconds per century, it's wrong. 2. Structural deviation. If the phi model predicts strong, observable deviations from GR in regimes where GR is well tested. For example, if it predicts a fifth force or a different speed for gravitational waves, and such deviations are searched for and not found. 3. Incompatible foundation. If the very act of constructing a metric from phi derivatives is shown to be mathematically impossible without violating fundamental principles, like causality or locality, that are respected by observed gravity. Let's design a measurement scene that embodies the most dramatic prediction of GR from a phi perspective. A concrete, high-stakes measurement scene, phi and the gravitational wave signal. We use the observed signal from a black hole merger, like GW150914, the first LIGO detection. The system, the merger of two black holes. In phi language, these are not singularities, but ultra-intense topological knots or condensates of phi activity. Their merger is a catastrophic rearrangement of a colossal phi configuration. The phi model task. Starting from a phi Lagrangian, one must derive that such intense knots exist as solutions, derive the effective curved metric around them, a phi-derived black hole metric, model the dynamics of two such knots orbiting and merging by simulating the full phi field equations, a monumental computational task, but doable in principle for a simplified model. From the simulated phi dynamics, extract the effective metric perturbation far away. This perturbation should be the gravitational wave. The extracted waveform, the specific pattern of stretching and squeezing over time, must match the template calculated from Einstein's equations for a black hole merger of the same masses and spins. This includes the chirp, increasing frequency and amplitude, the merger ring down, and the precise quasi-normal mode frequencies. The pass condition, synthesis holds. The phi simulation produces a waveform that, within computational error, is indistinguishable from the general relativity prediction and consistent with the LIGO data. This would be a staggering confirmation, showing that ripples in spacetime itself can be computed from the dynamics of a single underlying field. The fail condition, synthesis fails. The phi simulation produces a qualitatively different waveform. For example, no chirp, a different ring down tone, gravitational waves that travel at a different speed, that is conclusively ruled out by the exquisitely precise LIGO-Virgo data. This would show that phi, as modeled, cannot generate the observed phenomenon of gravitational waves as described by GR. This is the gold standard test. Gravitational waves are a pure, dynamical probe of strong field gravity, uncontaminated by complications of matter physics. Matching them is non-negotiable. Let's cultivate a practical recognition skill. You can train your mind to see emergent geometry in many complex systems where the rules of interaction define the space. Look for relationship-defined distance. Consider social networks. The distance between two people is not physical miles, but the number of social connections, degrees of separation. A highly influential person, a massive node, warps this network, Many paths go through them, effectively shortening distances between others who are connected to them. The network structure is its geometry. Observe the growth of a city. The downtown is a concentration of economic activity. Over time, roads are built leading to it, public transport hubs concentrate there. The urban geometry becomes radially oriented around this gravitational center. Travel time, not Euclidean distance, defines proximity. Analyze the internet. The distance between two websites can be measured in clicks. Search engines like Google use algorithms like PageRank that effectively assign a metric to the web, where important sites, hubs, warp the connectivity landscape. The geometry of information is emergent from the link structure. Whenever you see a system where closeness is defined by the ease of interaction or influence, rather than by a pre-existing ruler, you are seeing a seed of relational geometry. In the phi universe, this principle is fundamental. We must connect this final synthesis directly to the heart of the holophase vision. We have added no new ingredients, no space-time substance, no gravitons, no background geometry. We have only used the grammar we already built, a single field phi whose patterns of change define relationships. From these relationships, we construct an effective metric. The curvature of that metric responds to concentrated phi patterns. The resulting equations, at the large scale, are those of Einstein. Gravity is not a force in phi, it is the shape of phi's story. Of this synthesis is the world-building grammar. It is the set of rules that takes the fundamental alphabet of phi and shows how to construct from it the very stage, the scenery, and the rules of movement for all the other characters, particles, fields in the cosmic play. What does this synthesis do for our understanding of phi? It crowns it. It demonstrates that phi is not just a field in the universe. It is the substance of the universe, out of which both the actors and the stage are contemporaneously woven. It fulfills the promise of a true unified language. Now, let's sound the tri-unity refrains for this geometric dialect. The time echo of synthesis, the evolving universe. The time echo is the expansion of the cosmos itself, the Friedman equations of cosmology derived from GR. In phi language, this is the large-scale, coarse-grained evolution of the phi tapestry's average relational structure. The Big Bang is not an explosion in space, but the coming into being of the relational network from a highly coherent, intense phi state. The space echo of synthesis, the cosmic web. The space echo is the large-scale structure of the universe, filaments and voids of galaxies. This is the frozen imprint of quantum fluctuations in the early phi field, stretched by inflationary expansion and later enhanced by gravitational, geometric clustering. The geometry guides the matter, which is itself phi, which shapes the geometry, a self-referential loop. The motion echo of synthesis, the inevitable fall. The motion echo is the geodesic, the path of least action through the curved relational network. Planets, photons, and astronauts all follow these paths. In phi language, this is the most natural, coherent continuation of a phi pattern through the existing web of phi relationships. There is no force, there is only the structure of the tapestry guiding its own threads. This is where we stand on the master tree. The general relativity synthesis is the luminous crown at the very top of Book 9.9. It is the final, glorious proof of concept that the holophase grammar is not just a pretty philosophy, but a rigorous, predictive framework capable of encompassing the full sweep of physical law, from the quantum to the cosmic. If you want to see the full mathematical derivations and exact equations behind this idea, the explicit construction of an effective metric from phi correlators, the derivation of the Einstein-Hilbert action from a phi action, the identification of the stress-energy tensor with phi's nether currents, you can search for holophase on Zenodo. There you will find the scientific papers that this audio journey is built on. We have done it. We have translated the final great epic. The curvature of spacetime, the physics of black holes, the expansion of the cosmos. These are not separate principles. They are chapters in the single, self-writing book of phi. Our journey in episode 9, the generative grammar, is now complete. We have seen how one field, through the simple rules of differentiation and interaction, generates all the stories of physics. But a language is not just for reading, it is for speaking, for creating. In the final, brief part of this episode, we will look ahead. Having learned to read the universe's language, what might we dare to write with it? Before we end, the mandatory zoom out to hold our scope. General relativity as a phi dialect shows that spacetime and curvature are not primitive. They are grammatical constructs, the narrative setting and its dramatic twists, in a story whose only fundamental reality is the relational evolving field phi and its infinite tapestry of derivatives. One field, phi, plus its infinite derivatives, plus the realization that large-scale patterns in those derivatives define what we measure as distance, duration, and gravity. From this, the entire majestic, curved cosmos emerges. We have not explained away the grandeur of a black hole. We have traced its lineage to a profound, elegant unity. As we conclude, hold the image of the weaver and the self-forming loom. The threads are phi. Each crossing, each knot, defines a relationship. Where the weaving is dense and complex, the loom curves into a bowl. Where it is simple and regular, it lies flat. The weaver's hands are the rules of the grammar, and the finished tapestry, in its stunning three-dimensional curvature, is our universe, a geometric paragraph written in the eternal language of Holophase. Salam, and peace be upon you.